A serverless endpoint allows you to automatically scale the number of GPUs according to the number of requests that are coming in. This is useful for setting up production endpoints, and it's useful for training or testing if you want to make sure you don't have GPUs needlessly left on. By the end of this video, here's what you're going to have running. So this here is a serverless endpoint on RunPod, and I have a simple Mistral model running. Now I'm going to go over and inference this right away in my code base. I'm going to run some concurrent inference with 64 requests asking for the language model to come back with 64 paragraphs. So let's run this script for 64 concurrent requests. And you'll see over here in RunPod that automatically there are now being 2 workers that are being scaled. So that's 2 GPUs scaled in order to inference this request. And we can see the responses starting to come back here. And there we have it, 64 requests that have just come back from those 2 workers. And now that that worker is finished, it's going to scale down, and we'll be back to our baseline of just 1 worker, which makes sure that there is low latency with any initial requests that come in. So in this video, I'm going to take you through all of that. I'll describe the main use cases for using a serverless setup as opposed to just renting a GPU. I'll describe in detail how to set up the serverless using RunPod. Then I'll walk you through some inference demos, concurrent and single requests. And lastly, I'll talk about the cost comparison of doing serverless compared to renting a GPU and why you might do one versus the other. There are 2 main use cases I see. The first is training or testing. Often if I'm training a model, I need to go and deploy an instance on RunPod, VastAI, or some other service. And a problem is that sometimes I forget to turn off the GPU and I'm still paying for the rental. Also, every time I want to train, I have to spend time going to actually deploy the GPU. So if it's serverless, particularly for inference cases where I just want to quickly inference a model, I can also save time by having a serverless setup. And when I ping it, it will just turn on. Now, if I want to use it for testing, typically I'd recommend setting a minimum of 0 workers. That means that everything will shut down when it's not being used. However, I usually set the idle time a little bit higher, so I don't want the last worker to turn off unless 300 seconds or maybe even longer has elapsed. I'm quite happy to pay for 5 minutes, even if I'm not using it, just to save the time of a cold start, which can be about 1 to 2 minutes. But I don't want the idle time to be 5 seconds so that if I make a request and then 5 seconds goes by, it shuts down and I have to cold start again. Now, the next use case is a production server where I want to allow for many workers potentially that scale with the number of requests coming in. So that is, of course, the main benefit. If I just rent a GPU, there isn't going to be extra space if my GPU gets overloaded. The settings here, typically I'll set a minimum of 1 active worker. This means I do have to pay for at least 1 worker, although it's 40% discounted, that 1 minimum. And then if I need more workers, they will be charged in addition and scaled automatically. Here though, I can set a shorter idle time because I've always got that 1 minimum worker that's available. Moving on to the setup, I'll take you through all the steps. This is all described in the Advanced Inference repository. You can find more details on Trelis.com and purchase lifetime access. I'm always adding new scripts to this repo, so once you buy it, you've got access to anything I upload in future. Now, there are a few steps here, starting off with getting set up in RunPod. If you don't have an account already, you can make use of this affiliate link here if you want to support the Trelis channel. Once I've logged into RunPod, I'm going to first set up a storage volume. And I'll do that by just going down to the storage option. Now, this provides a specific volume in a specific region of the world in a certain data center, and the weights will be downloaded to this volume. And this is beneficial because it means the weights are downloaded once, and you save that download time every time a new instance is going to boot up. If you don't use a storage volume, you can have the weights downloaded to each individual instance. But the problem is that will slow down inference. So for the quickest startup times, it's probably best to set up a network volume. So I'm going to set one up here for Mistral, and I'm going to make it 15 gigabytes in size because I'm going to inference this in 16 bits, and the weights are going to be roughly 14 to 14.5 gigabytes. Now I'm going to choose Europe South because I found that this is where there's good GPU availability. This is important to consider as well, because when you set up a volume, you're limiting yourself to the GPUs within that region where the volume is. If you have a volume in Northern Europe, you can't use GPUs in Northern America. So I've chosen Europe, SE, which probably means South Europe or something like that, and I'll create that volume. Now that I have the volume, I'll be able to go and start with the serverless setup. So I'm going to go to Serverless and click on New Endpoint. Let's set one up for Mistral. And here I'm going to choose the types of workers. Now Mistral is about 14 gigabytes if loaded in 16 bits, so it will fit on any of these GPUs. Typically, I'll pick the 24 gigabyte and the 48 as well, just to give more options for available GPUs. Although if you really want to minimize cost, you should just pick the 24 gigabyte one. Now, if you want larger models like say Llama 70B or Mixtral, which I describe in the instructions, you're going to need larger GPUs. You can run those in AWQ, which is a quantized format, and they will fit on 48 gigabyte GPUs. So if I was running those larger models, I wouldn't select the 24 gigabyte GPU, I'd just select the 48 gigabyte one. Moving on here, I've got the option to set the number of active workers and maximum workers. If I'm in production deployment, I'll set a minimum of 1 active worker to make sure that there's no cold start. When somebody makes a request, they won't have to wait a minute or two for that worker to start. It will always be running. Then I'll set the max workers. This really depends on what you think your max load is going to be. I would say typically you can allow for inference of maybe 32 parallel requests, maybe even 64 or 128. So you can think and try out different volumes of requests. Typically I'll allow for about 32 parallel requests per GPU. So if I think the max request I'll have is 64, then I'll set up 2 max workers. Here's the idle timeout. If I don't have any active workers, I'll set this longer just to avoid it shutting down and having to restart. But if I have minimum 1 active worker, I can just allow extra ones to shut down if they're not being used. Next up, I'll always turn on flash boot. This speeds up it makes it faster for the weights to get loaded onto the GPU into the high bandwidth memory. And this is going to reduce the startup time. And yeah, just a note here that it reduces cold starts down to 2 seconds. I mean, it's true, it can get the loading time of weights down really short, but the problem is starting up an instance, there's often the instance setup time, and that ends up adding as well. So if you don't have any active workers, in practice, I find you have to expect maybe 45 seconds or more time for startup. Okay, execution timeout you can think of as how long do you want any one request to last before it times out. You certainly want this longer than the generation time for any of the responses you're expecting back. 600 is about 10 minutes, so that's probably quite long and fine. Next up, you can select a template. I recommend saving your setup as a template if possible. Unfortunately, these aren't shareable right now, so I'm not able to share with you my templates. So instead, I'll just describe how to set these up. So in setting up the container, you need an image. I recommend using the CUDA 12.1 image. So I'm just going to copy it from here, from the instructions. So I'll use that image, and my container disk needs to be at least as large as the size of the largest weight. So I will typically leave it at maybe 10 gigabytes for the Mistral model. You may need to leave it bigger if you have large AWQ weights. Maybe your AWQ weights on Hugging Face are 25 gigabytes, so you'd need a larger container then. Next up are the environment variables, and there are a few ones to set. So the first one to set is the model name. And the model name here is going to be Mistral. So I'm just going to get that. So here I am on the Mistral repo, and I'm going to copy that model name in here. Next up, I'm going to put in an environment variable to speed up the downloads. So this one here is going to be HF hub. And actually, I'm going to copy it from the instructions because I don't remember. So it's HF hub enable HF transfer. And you can set that either equal to true or just a value of 1. The next one here is max model length. So I'm going to set max model length to 4096. You can set this longer, but it means that you're going to take up more memory on your GPU and you risk more easily running out of memory. So you'll have to play around with increasing this based on how many GPUs, the size of your GPUs rather. Now, there is an option as well where you can set the number of GPUs per worker. So if you're just using the 48 gigabyte, you're able to set 2 GPUs. So that would allow you 96 gigabytes. So you could actually fit a model like Yi in full precision on that, for example. Okay, so I have max model length, and there is an option here where I can add enforce eager. This basically avoids VLLM from calculating the CUDA graph, which does speed up the inference, but can take extra VRAM. I don't recommend turning this on unless you're really running out of memory. You would turn it on by putting in enforce eager and setting that to 1. Now, just 2 other notes. If you're running an AWQ model, for example, if you're running Casper Hansen's AWQ model for Mixtral, let's take a look at it. So here we can see the weights. I think the weights are chunked into 10 gigabytes. Yeah, so you can use a 10 gigabyte container size. And also, if you're going to use this model, so you would put in the name here, you're also going to need to set the quantization type. So you'll have to put in quantization and set that to AWQ. And you'll also have to set the data type. The data type right down here would be set to half. So I put in something like D type and then set that to half, like that. Now, I'm not running quantize for Mistral. There's no point because I can fit the full 16-bit weights within the GPU, and it's actually faster not to do the quantization and dequantization. So I would only recommend using quantization if you want to save on number of GPUs for larger models. With that, we're ready to move on to the advanced section. So here we're going to select the network volume. So we're gonna say that the weight should be downloaded to the Mistral instruct volume. Notice that does limit us to the data centers in EU South. And you can see now that the availability of GPUs has changed. And that's why I pick these 2 here. And for the allowed CUDA versions, since we're using an image that is CUDA 12.1, I'm going to restrict the allowed CUDA versions to these versions here. Now, there are 2 ways to control the scaling of GPUs. The first is delay. So if there's a delay of 4 seconds on a request, it will boot up another worker. And the other way is request count, which is the way I'm going to use. And I'll set it to 32. So if there's more than 32 requests that are either being processed or coming in, then that means it's going to spin up a new worker. And with that, everything is set up for the endpoint and I'm ready to deploy. And here's my endpoint. What's going to happen is there should be a first worker set up because I've set a minimum of 1 worker. We should see the container is going to initialize. And after that, the weights should begin to be downloaded. And of course, they're going to be downloaded on the volume that we have specified. So here you can see it's initializing an LLM engine. Notice that the image is going to be deprecated soon. I will update that image to a new one shortly in the GitHub repo, but it will work fine for now. And here you can see the GPU is now being loaded with the weights. So GPU memory is going to go up and we should see the model is going to be loaded there. Now, in the meantime, while that's loading, I'm going to go and open up advanced inference in VS Code. The section I'm going to use is the API calls section. So if I navigate through the code and go to API calls, I'm going to take a look at the speed tests. And the tests I'm going to run are going to be the VLLM speed concurrent and also the standard speed test. So let's take a look in VS Code. Note that I'm going to just activate a virtual environment. So I'll do source and my virtual environment is 1 folder up. API env bin activate. And with that activated, I'm ready to run a simple speed test, which is just to generate 500 tokens. It's a paragraph about Spring. I can easily adjust that as well. If I just want to produce, say, 5 tokens, I can do a very quick time to first token test. And then I'll run a concurrent test where I send in requests every 16th of a second, and I'll send in 64 requests. And that will give us a sense of concurrent performance. So the first test I'll run is just Python VLM speed.py. And we can just go back over to check that the endpoint is up and running, which it is because the memory is up towards max, which means VLLM has fully loaded the weights. So here I'm just doing run request. And I forgot to mention something, which is that I need to set my environment variables. So back over in the env file, I need to do two things. First, I need to set my API endpoint for runpoint serverless. Typically, we would set the run point like this if we're using a rental GPU for either TGI or VLLM. But here, the API endpoint needs to have this format, and I need to replace in the ID of that serverless endpoint. So I've placed that in there. And down here is my runpod API key. I'll delete this after the session. But you should be able to see here, if you go to settings, and you can click on API keys and create a new API key right here. So with that, I've just got to set the model name, and I'm setting the model name to the Mistral model that I have here. So now I should be able to run VLLM speed. And indeed, I get back a response within about 2 seconds, and it generates 5 tokens, so about 2.5 tokens per second. And indeed, that's a slow token per second, because when you do a short number of tokens, most of the latency is the time to the first token. We can now repeat that test for 500 tokens of generation. So it's generating a paragraph now about the season of spring. You can see my request to the language model is just down here, write a long essay on the topic of spring. And here we have that response. You can see the paragraph about spring comes back here, and it takes about 21 seconds. So we've tokens per second of 23 tokens per second. And I can run a concurrent test with Python VLLM speed concurrent.py. And this is sending in those 64 requests spaced out by 1/16th of a second on each go. And just notice here, if we go back to our server, or rather our serverless, you can see that it has ramped up 2 of these GPUs, as I showed right at the start of the video, because 64 requests exceeds the 32. And once that's exceeded, it boots up that second server. So you can see a newly started server here and the one that we started about 5 minutes ago. And with that, I can go back to VS Code, and you can see here that it's able to generate these 64 requests at about a rate of 14 tokens per second. So you can get very high inference volumes, high numbers of tokens produced if you do this concurrent request approach with a VLLM endpoint. Before I wrap up, just a few notes on costing here. So if you were to normally rent an A6000 from RunPod, that will cost 69 cents per hour. If you rent serverlessly, you'll be paying $0.00048 per second, which is about $178 per hour. So you can see the cost of serverless. The GPUs are being rented at 2 to 3 times the price of just renting it consistently. However, you only pay while you're running. So the maths here is that serverless makes sense if you've got less than 35% capacity factor. So basically, if you're going to be making requests less than 1/3 of the time, then it probably makes sense to take a serverless approach rather than just paying for the servers outright. Now, I will say that there's an implication here that if you have a really high load and you have a really high consistent load, then at some point, because you're paying so much more for using serverless on a per GPU basis, it's going to be worth setting up your own custom algorithms that power up and power down GPUs dynamically. So I think really where serverless is a sweet spot is if you're moving towards production and you've got a growing number of requests, but you're still kind of in the range of maybe 1 to 5 or 10 GPUs. If you go up beyond that, then the economics are going to drive you towards building your own custom setup, just so you're not paying that premium for the serverless time. Now, just one other quick point, which is that if you are running in production, you probably want to have at least one active worker. And if that's the case, RunPod charge 40% less for that initial active worker. So actually you'd be paying 1.07 instead of 69 cents. So it's actually, the difference is a bit smaller for that first one. Whereas the additional workers, you're paying a larger premium of closer to 2.5x. So actually this further helps the case for using serverless. All of the scripts for this demo are included within the Advanced Inference repository. If you don't have lifetime access already, you can get that at trelis.com. That's trelis.com. In the meantime, let me know any questions in the comments below. Cheers.